Greetings. Welcome to week 4 of cryptography and data security. Last week we talked about public key cryptography, talked about public keys, private keys, and including the RSA and elliptical curve. This week we're going to talk about focusing on hiding data to protecting data integrity and authenticity. Make sure that the person who is either receiving or sending the data is authentic. Today's lecture is about understanding the concept of hashing and how it differs from encryption. So we've been kind of concentrating on encryption, but hashing is another method for basically securing information. And how digital signatures prove trust. We're going to talk about what they are, how they're created, and how they're used in this world of data security. What is a hash function? A hash function is a mathematical process. Takes on data of any size, okay, and produces a fixed size output called a hash value or message digest. So it's a transformation of taking information that we want to protect and taking that information, running it through a hash function, and getting out something that will represent what we're trying to encrypt. You can think of a hash function like a digital fingerprint. You or you on your fingers, you have fingerprints. Those fingerprints identify you. That is what we're producing with a hash function based on the data we're trying to encrypt. The fingerprint cannot be used to recreate the original data. Small changes in data create completely different fingerprints. Key to remember. The desired properties of a good hash function. What do we want to come out of a good hash function? For a hash function to be used in cryptography, it must have several important properties. Some of these we basically have seen before, but we're going to look at them in a little different manner. Deterministic. Deterministic means that the same input will always produce the same hash function output. If you hash the same file twice, you get the same results, okay, in both times. We want the hash function to be irreversible. Irreversible means you cannot take the hash function and figure out the original input from that hash function. Hash functions are one-way functions. Collision resistant. Collision resistant means that it's extremely difficult to find two different inputs that will produce the same hash function. We don't have to worry. That's what a collision is. I have two different things. I hash it, and I have a collision that is giving me the same hash function. We want a hash function that will be collision resistant. It's extremely difficult to find two inputs that produce the same output value. Collisions are possible in theory, but a secure hash function makes them very impractical. Not impossible, but impractical. How does the message digest 5 algorithm MD5 works? This is a hashing algorithm. The message digest 5 algorithm, the MD5, commonly called MD5, is a hash function that one takes input data, processes it in blocks, and produces a 128-bit hash value, MD5 was once widely used, but today it's considered to be broken. When broken means that those who do not want to get to the data are able to figure out, okay, how the hash function basically translates back to what is being encrypted. It is vulnerable to collisions, okay? We just said, so I can get two different items that I want to get a hash function for and get a collision with the same hash. It should not be used for security purpose. MD5 still discussed in this course for historical and education, which means that we're looking at MD5 as basically a baseline of where we were, and that we're basically taking that information and showing you where we are now. Okay, so we went from something that was used, it was pretty good at the time, but became outdated as, I guess, individuals, hackers have gotten more devious, okay, in figuring out how they could break the particular hash function. Okay, the secure hash algorithm family. This is the SHA. Okay, the SHA family. Secure hash function one, SHA-1 produces a 160-bit hash value. Now consider not considered to be insecure. Excuse me, now considered to be insecure. It is vulnerable to collisions. Okay, so that's not good. Then we have the secure hash algorithm, 256. It produces a 256-bit hash value. Now you notice as we go through these families, the basically the size of the hash function gets bigger and bigger. Okay. As a hash function, just like a key, the bigger it is, the less likely somebody can figure out what is being hashed from. Okay. So 256-bit hash value, part of the security hash family, family widely used and considered secure. Other inversions include the secure hash 384, the secure hash 512. And again, these are 384 bits, 512 bits. Bigger, bigger, bigger. The bigger the field, bigger the hash, okay, then less likely somebody can break it. Hashing versus encryption. Okay, so let's talk about that distinction. What's the difference between the two? Students often confuse hashing and encryption, but they serve different purposes. Hashing is one way. It's a one-way process. No keys used, cannot be reversed, used for integrity checking and password storage. We'll hash a password. Encryption, two-way process, uses a key, can be reversed or can be decrypted once we encrypt it, used for confidentiality. Okay. Key takeaway, hashing protects integrity, encryption protects confidentiality. Okay. What is the hash-based message authentication code? HMAC. Hash-based message allocation code, commonly called HMAC, combines a hash function with a security key. The purpose of HMAC is to verify that the message has not been changed, verify that the message came from someone who knows the secret key, and only people with the secret key can create a valid HMAC. Okay. So we basically combine the key feature in with the hashing feature in order to get something that's even a little more secure on both ends. How HMAC works conceptually. A secret key is shared between the two parties. The key and the message are combined. A hash function processes the combined data. Then the result is an authentication code. If the message is altered, the HMAC will not match. The change is detected immediately. Okay. So basically, it's basically says that for authentication, I need to know that you are who you say you are in order to untangle this web of encryption. Okay, the HMAC does that by combining the key with the hashing function itself. Okay, I know you've seen this before. What is a digital signature? A digital signature is a cryptographic technique used to, one, prove who sent the message, ensure that the message has not been altered, and prevent the sender from denying they sent it. Okay, non-repudiation. Okay. Digital signatures use a private key to sign and a public key to verify. Okay, how digital signatures work? This is on a high level. The sender sends a hash of the message. The sender encrypts the hash using their private key. The encrypted hash becomes a digital signature. The recipient decrypts the signature using the sender's public key, recomputes the hash function of the message, and compares the two values. So if what I sent is not equal to what was hashed before, okay, then we know that we don't have a match and something's wrong. Yeah. One of the key things here as far as, proving who sent the message and sure the message has not been altered and prevent one of these things failed, okay, in this particular case. If they match, the message is authentic, the message is intact. Integrity non-repudiation, explained. Integrity. Integrity means the data has not been changed in transit. Hashing and digital signatures both protect integrity. Non-repudiation, we talked about that, means that the sender cannot deny sending the message because only the sender has the private key, and signature and digital signatures provide non-repudiation. So in looking at in the summary for week 4, and again, as the other cases, we're going to be jumping into your project, and your project, you're going to be kind of flushing out this with the VS Code as far as setting up examples we can actually see what's happening. Excuse me. So by the end of the week, you should understand hash functions create fixed size digital fingerprints. Good hash functions are deterministic, they're irreversible, and they're collision resistant. Message Digest 5, MD5, and secure hash algorithm SHA-1 are no longer considered secure. Secure hash functions 256 and newer versions are widely used. Hashing and encryption have different purposes. Hash-based message authentication codes call authentication using a secret key. Digital signatures ensure integrity, authentication, and non-repudiation. Okay. What I recommend if there's some concept that we're not covering in class, okay, look it up. Look it up. One of the things that I kind of expressed in my classes is that I don't know, not only want to give you information, and that is the scope of your information that you receive, but if you see something and you say, well, I don't understand quite what's being said here. Look it up. Use chat. Okay, it's out there. It's a resource. Use it. It will explain a lot of things that maybe that you could quickly find the answer to, rather than swimming in the deep water trying to figure out what it's saying. Investigate. When you get out there in the real world, there are going to be things that you don't understand, things that you don't know, but your employer is looking for you to be able to dig in and find out what the answer is. This is an exercise in that, and in information that you may not understand. So in closing, this week's concepts are used everywhere. From securing websites to software updates to digital contracts. Understanding these ideas is more important than memorizing algorithms. And we're not really talking about, what's involved in MD5, what's involved in SHA, what's involved in HMAC, but what does it do? Okay. And a good example of that is when we look at our projects. We are basically taking things that have already been created and basically exercising, putting the input in, getting the output out, seeing how those differ from the various hashing functions that we've basically been discussing. Okay, so again, understand those ideas are far more important. Next week, we're going to talk about secure communication protocols and real-world applications. See you soon. Have a good one.